This presentation is for Lab 1 charge tapes for Physics 2 at Georgia Tech. The purpose of this lab was to become familiar with the following ideas: charge as a property of matter, designing experiments, making estimates and simplifying assumptions, and excess charge on everyday objects. The primary goal was to determine the amount of excess charge on one piece of clear tape. To summarize my results, I got a tape charge of 1.7 times 10 to the negative 8th coulombs. To complete this lab, I needed a series of physics concepts. Coulomb's law defines the force due to an electric field as the constant K times both charges divided by the distance between them squared. The electric field is defined as K times the charge over the distance squared. In addition, the gravitational force is defined as the mass times the acceleration due to gravity. Finally, Newton's first law states that objects in equilibrium must have a net force equal to 0. The experimental model for this experiment can be broken down into 3 parts. Part 1 was to make charge tape. Part 2 was to observe the U-tape interactions, and Part 3 was to estimate the excess charge on the tape. In Part 1, I made a charge tape. To do this, I obtained a 20 centimeter long piece of tape and folded over a small portion of it as a non-sticky handle. I stuck the tape down on the desk, pressing it down with my fingertips. I made an identical 20 centimeter long tape with a non-sticky handle, but I drew a U on this one, and I stuck it on top of the base tape. With a quick motion, I pulled off the U-tape from the base tape, holding the base tape down. Hanging the U-tape off the desk, I handled it as little as possible. My observations were that when I held the non-sticky handle with one hand and brought my other hand close to the tape was attracted to my hand, meaning it was charged. In Part 2, I observed the U-tape interactions. I made 2 identical tapes similar to Part 1. Then, I observed the interactions of the U-tapes when they were brought closely together. I observed the interactions of the U-tape when they were brought close to a neutral object. Then, I rubbed a clear plastic pen on a cloth and determined the charge of the U-tape. My observations were as follows. When the 2 U-tapes were brought closely together, they repelled each other, indicating that they had the same charge. When the U-tape was brought near a neutral wooden block, it was attracted to it. When the clear plastic pen was rubbed on the cloth, it became negatively charged. When the pen was brought near the U-tape, they were attracted. Therefore, the U-tape must be positively charged. The third part of the experiment was to estimate the excess charge. I did this by sticking one U-tape in between 2 objects of equal height, hanging it like the picture, and making sure that there was enough slack. Then I brought a second U-tape underneath the hanging U-tape. I slowly moved it closer until the tape that was hanging began to float. Once the hanging U-tape began to float, I recorded the distance between the 2 tapes at that time. My observations were that the hanging U-tape began to float when the second tape was 2.5 centimeters underneath. To perform these calculations, I first assumed that each U-tape had the same net charge and that the charge was centered around one point. First, I found the gravitational force using the mass, which was 1.96 times 10 to the negative 3rd newtons. Then, I found the charge of the tape by equating the force due to the electric field and the force due to gravity. This ended up being 1.17 times 10 to the negative 8th coulombs. Then, I found the electron deficiency by dividing the total charge by the charge per electron. Using the electron deficiency in combination with the total number of atoms on one side of the tape, I was able to find the ratio between deficient electrons and total atoms, which is 2.86 times 10 to the negative 7th. Possible sources of error included the following things: overhandling the U-tapes, unequal charges of the 2 U-tapes, too much tension on the hanging U-tape, and inaccurate gravitational force estimates of the U-tape. My GlowScript code confirmed my answers that I obtained in the calculation section. A screenshot of the code can be seen here, and the link here as well. My model shows the electric repulsive force between the 2 tapes as red arrows. The gravitational force on both tapes are shown in blue. Finally, the light blue arrow shows the force of the supportive hand holding up the bottom U-tape. The 2 U-tapes are represented by green point charges. If the charges of electrons and protons were reversed, the interactions would essentially be the same. The tapes would still be the same charge, so they would still repel each other. We could still find the charge using the same method. In addition, it's important to handle the charged tapes as little as possible because electrons are transferred between objects. So, when the positively charged tapes that are electron deficient come into contact with hands, electrons are transferred. Over time, the tape would no longer have a charge. Thank you for listening.